I want the equation of the tangent line. Our curve is 5 over x squared minus 2 over x cubed. I strongly recommend, if your denominator is a single term, rewriting them as negative powers, so 5x to the negative 2 minus 2x to the negative 3. To write the equation of the line, we need a point and a slope. We have a point, negative 1, 7. I need a slope. The slope of the tangent line is the derivative. So first we do our derivative. So the derivative of this, we can just do our power rule. So that would be negative 10x to the negative 3 plus 6x to the negative 4. I know my x is negative 1. If you want, you can rewrite it back in this form, negative 10 over x cubed plus 6 over x to the 4th, if that's easier for you to calculate. So then if we plug in our negative 1, okay, negative 1 to the 3rd is negative. Negative 1 to the 4th is positive, so we get 10 plus 6, which is 16. So now we know our slope. So then our equation, y equals mx plus b. So if we add that over, b is 23. So our tangent line is 16x plus 23. Okay? Number 2. So there are different ways you can write it. You just have to have an equivalent answer at the end. We can't rewrite this without a denominator because no matter what, I have x squared over e to the x. I can't simplify that. So I'm going to have to do my quotient rule here. So quotient rule is low, d high, derivative of the top is 6x, minus high, d low. Okay, the 2 is just a coefficient, it stays. What's the derivative of e to the x? Over low squared. So now if we multiply, we get 12x e to the x minus 6 e to the x, or 6x squared e to the x. Over 2e to the 2x. Can we reduce this a little bit? If we look at our numbers, 12, 6, and 2, I can divide all those by 2. Okay, I don't have an x and everything, so those are going to stay. I also have e to the x, e to the x, and e to the 2x. So if I take an e to the x out of everything, that would take one of those. So at this point, all you have left is 6x minus 3x squared over e to the x, 2e to the x. I have a mistake right here. I didn't square my 2. That should have been a 4 when I squared it. So then when I divide it by 2, it leaves a 2 on the bottom. So 6x minus 3x squared over 2e to the x. I'm not asking you to go too crazy with your simplifications, but I do want the obvious stuff. So multiply out, combine like terms. If something nicely cancels off top and bottom, go ahead and do that. Okay, so just the basics here. All right. Is there anything else on that first page?
No, number 5.
Number 5? Take a look. You have 2 options right now. You can keep it as written and do your derivative, so you'll have to do the quotient rule twice. Or you could get a common denominator first to get a single fraction and do quotient rule once. I don't care, they'll both be equivalent. So which way did you guys do?
I did quotient rule twice.
Quotient rule twice? Okay. So if I do that, this one, low, d high. What's the derivative of 1? Minus high. D low, what's the derivative of x plus 2? Over low squared. Minus, so we do the quotient, what's the second one? Low. D high, derivative of the top is minus high. D low, derivative of the bottom is 1 over low squared. So x minus 2 times 0, that just cancels. Minus 1 times 1, so we get negative 1 over x plus 2 squared. Minus, that cancels. Negative 1, so I could say plus 1 over x minus 2 squared. Let's take a look at problem 8. There are two ways of doing this problem. We can do quotient rule, or, because my denominator is just a single term, the 3 is multiplied with the x cubed, so it's one term, you could divide each of these things by 3x cubed and then do the derivative. Again, I don't care. Your answer looks a little bit different, but they're mathematically equivalent. So do you want to simplify first or do quotient rule? Don't everybody speak at once.
Yeah. Simplify.
Okay. So, 8 over 3x cubed minus 5x or 4 over 3x cubed minus x squared over 3x cubed. So this would turn into 8/3 times x to what power? Minus, this would be a 5/3, 4 minus 3 is just x to the first, minus, my coefficient, it's like a 1/3, x squared over x cubed, if you subtract those, x is negative 1. So then we can do our derivative. Exponent comes down, so 8/3 times negative 3 is negative 8. X, subtract 1 from the power, so negative 4. This one has a power of 1, so if you bring down your 1, 1 times 5/3 is 5/3. If you subtract 1 from your power, you get x is 0, which is just 1, so that goes away. Here, if I bring down my negative 1, so that would be plus 1/3 x, subtract 1 from the power, negative 2. If you had quotient rule, if you had done quotient rule, it would be equivalent. You have a big fraction, but if you divide each term, it should be equivalent to this one. All right. Is that okay with everybody? Number 12. So b of t equals 5 t to the third minus 6 times secant of t. All right, so our derivative. We can distribute this secant if we want, but no matter what, we're going to have to do the product rule because I have a t here and with my trig function. So if I just go into my derivative, the product rule, does it really matter which one you do the derivative of first? No, we just do one at a time. So if I do the derivative of the first one, 3 comes down, so that would be 15t, 3 minus 1 is 2, minus derivative of 6 is 0. So that's 15t squared times the second one, times secant of t, plus the first one, 5t cubed minus 6, times derivative of the second. What is the derivative of secant?
16t.
At this point, that's really all you could do. If you wanted to like factor out a secant or something, you could, but nothing, we have no like terms, so it's not going to get any nicer for us. Is there anything else on this page you would like to look at?
If we did distribute that, we don't need to FOIL that, don't we?
No, it would just be like 5t cubed, secant t tangent t, minus secant t tangent.
Perfect, thank you.
You're welcome. Other questions? All right, problem 16. So if we are doing our derivative, we can't get rid of the quotient. We have two terms on the bottom, so we couldn't simplify even if we wanted to. So we have to do quotient rule, so low d high, what's the derivative of sine? Minus high d low. So the derivative of 4 is 0, plus what's the derivative of cosine? So on the top, that's 4 cosine x, plus cosine times cosine is cosine squared x, minus sine times negative sine would be negative sine squared, so minus negative is plus sine squared x. All right, we are very close. There is one thing I would like for you to recognize here. What is cosine squared plus sine squared? 1. That's like one of the only trig identities I expect you to know because it is so helpful in some fine problems. So we can turn that into a 1. And this would be our final answer. All right. Problem 17. So we have 5 times the square root of x to the 5th minus 3x squared. I want f double prime of 16. Can I plug in my 16 first before I do derivatives? No, if I plug it in right now, I get a number. And then what's the derivative of a number? 0. So you can't plug in until the very end. Okay, we have to do our derivatives first. So it would probably be helpful to rewrite this without that radical. How would I write the square root of x to the 5th?
X to the 5 over 2.
So our first derivative. This is where labeling becomes very important. If I bring down my exponent, 5 times 5 halves would be 25 over 2. X, if you subtract 1, so 5 over 2 minus 2 over 2 would be 3 over 2. Minus, bring down my 2, x, subtract 1 from the power. That's my first derivative. I asked for the second derivative of 16, so now I'm doing my second derivative. So if I bring down my 3 halves, remember if you're multiplying fractions, you just multiply the tops, multiply the bottoms. So you get 75 over 4. X, 3 halves minus 1. So 3 over 2 minus 2 over 2 will be 1 over 2. Minus 6, derivative of x is just 1. Now we can plug in our 16. Okay, we don't have a calculator on the test, but we don't need one. A 1/2 power is the same thing as saying the square root. Square root of 16 is 4. So you get 75 minus 6 or 69. Okay, so this one, I'm again asking for second derivative. Label, so you know when you have the first and when you have the second. Even if I distribute my E, that's not going to help me, because then I just have to do the product rule 3 times instead of just once. The reason we have to do the product rule is there's x's in this parentheses and the E has an x with it. So, derivative of the first. So 3 comes down, so that would be 9x, subtract 1 from the power, so squared, minus 8x, plus the derivative of x is just 1, e to the x, plus the first, 3x cubed minus 4x squared, plus x. Derivative of the second, what's the derivative of e to the x? All right, but now I need the second derivative. I would recommend cleaning this up just a little bit, because right now I have to do the product rule twice, not that that's impossible. But if you notice, what do both of these terms have in them? E to the x. So if I take out that e to the x, there's an x squared plus 8x plus 1, plus 3x squared cubed minus 4x squared plus x. We can combine some like terms. So we have 3x cubed plus 5x squared minus 7x plus 1. Okay, you didn't have to do that there, but at some point we're going to have to combine some like terms. So probably nicer to do it before you do the second derivative. Then we just have to do product rule one more time. So derivative of the first, derivative of e to the x is still e to the x, times the second one. Plus the first, e to the x, times derivative of the second. So derivative of 3x cubed would be 9x squared, plus 10x minus 7. Again, I do want you to combine any like terms, so what would we have to do here?
So, yeah, either x's or just take it on the outside.
Yeah, we have 2 terms, both have an e to the x, so if we take that out, and combine like terms, we have 3x cubed. Did you guys do okay?
Yep.
Alright. 14x squared plus 3x, 1 minus 7 would be negative 6. And that is finally my second derivative here. Is that one okay? All right, you guys were good with problem 19? Anything else on that page we need? So problem 22. This one is just extra beautiful here.
Let
Let me see how well I can draw this to start with. Okay, so. That's one of them. I am not going to get this right when I'm drawing. actually, here, give me 1 second. I'm just gonna copy it off my study guide. So, here's my graph. We're trying to figure out which one is which. So just pick one to start with. Looks very overwhelming at first, but I just pick one. So if I start with this green one. Here we have a maximum. If you think about the tangent line, the tangent line would be horizontal there. So its derivative should be 0. Right here, we have a horizontal tangent line, so the derivative should be 0. Horizontal tangent, so its derivative should be 0. It was increasing, so its derivative should be positive. Decreasing, so negative derivative. Increasing, so positive derivative. Decreasing, negative derivative. So what's the derivative of the green one? Blue. Okay. So if I go to that one next, we look. Anywhere it has a maximum or a minimum. So right here, we had a min, so its derivative should be 0. Max, so derivative is 0. Check increasing, decreasing. It started out decreasing, so its derivative would be negative. Then it was increasing, so its derivative should be positive. Then decreasing, so negative. So the orange one follows that pattern. So that means this is my function. The blue one, so this one right here, was my first derivative. The orange, so this one right here, had to be the second derivative. All right, so my suggestion on that type of question, you pick one and you start with it. Look for maximums and minimums, and then check increasing and decreasing from there. 23. Okay, I'm asking you where the derivative does not exist. So, remember, there are 3 things that make a derivative not exist, and I drew you a graph that had all 3 to illustrate it. The first thing is any discontinuity. Okay, we know the slope of the tangent line as you're coming in from the left and right, your limits would be different, so that wouldn't work. So that's when x is 1, sorry, negative 1. So that's the first reason that you would not have a derivative. The second thing that causes a derivative to not exist is a corner. Because at corners, there is not a unique tangent line. So right here, anytime you have that sharp corner, so when x is 0, there is not a unique tangent line, so there is no derivative. The third thing, derivative is the slope of a tangent line. What's the slope of a vertical line? Undefined. So anywhere the tangent line would be vertical, the derivative doesn't exist because the slope is undefined. So if I look right here, this would be a vertical tangent. So it's like that sharp increase if you're just going straight up. So if you would have a vertical tangent line, your derivative doesn't exist. So those are the 3 scenarios you need to look for. Is that okay? The definition. So you have to know the definition. If I ask you to do it with the definition, you have to show me all the work. You can certainly use our other rules to check yourself, but you have to be able to do this. Our function is 4 over 3 plus 2x. Make sure, a couple of you are really bad about this, but you write the limit up until the moment when you plug in the 0 for your h's. So I have the limit as h approaches 0. F of x plus h says I go to this function, and I plug in x plus h for my x. Minus f of x is just my original function. All over h. Can I just plug in 0 for my h yet? No, because it's divided by 0. We can't do that. So, what's your suggestion for the top?
Like denominator.
Yeah, if we want to add or subtract, we need a common denominator. So, this one needs 3 plus 2x on top and bottom. This one would need the 3 plus, can I just write it as 2x plus 2h if I distribute my 2? So we get 12 plus 8x over our denominator minus, distribute our 4, so 12 plus 8x plus 8h over our denominator. And that is all over h. Fairly ugly at the moment, but it should be getting better. If I want to subtract, we have to make this a plus and distribute that negative. 12 and negative 12 cancel. 8x and negative 8x cancel. So I have negative 8h over my denominator. I'm going to go ahead and put them together. Divided by h, that's like h over 1. So to divide by a fraction, you flip and multiply. So what happens now?
H is canceled.
You cancel the h. Now I'm no longer getting 0 on the bottom. So this is the moment when you can plug in 0 for your h and drop your limit symbol. So we get negative 8 over 3 plus 2x plus 0 and 3 plus 2x, or negative 8 over 3 plus 2x squared. And on tests, if you were in doubt, you could always do the quotient rule on the original to check yourself. In case Bryson wants